Hi, I'm Mayank.
Hi, I'm Dylan.
And I'm Brandon. Here we have our finished project. This part, as you can see, we've got our glove with flex sensors attached to the fingers, sending data to this Arduino. We have our joystick and button attachment, which is totally not a nunchuck, sending data to this Arduino, which both forward their data to this Arduino, which sends its data through USB to our computer.
We have the glove where we connected and attached all the flex sensors to. Each one is soldered to wires that we also did ourselves. We put paper around each sensor so that it was not resting directly on the glove. And to secure each sensor down, we taped it using electrical tape. We also taped the base where all the wires connect initially to relieve tension off each flex sensor, as well as to relieve the visual strain of all the wires connected.
Here we have our 3D printed joystick and button attachment. So we've got our joystick here and two buttons here on the end. You can also press the joystick and use that as a button. So if we open it up here, you'll see that it's printed in two parts, a lid and a base. Fortunately, the lid broke a little bit. So we've got the joystick in the middle here and the two buttons over here in the front. If you lift up the joystick, you'll notice it's slightly elevated so that we can run wires from the buttons in front down through the back. Attached to the glove here, we have an LCD screen and a button. Now, normally this LCD screen would be displaying our values that are being read in from the flex sensors, but that is one part of the project. The code is all there, but the screen just is not working right now. And next to that screen, we also have a calibration button. That's the yellow button right there. When you press that, the base values that the Arduino expects from the flex sensors get reset to whatever their current value is. And even though you can't see the calibration information on the screen right now, it still does work.
Now, these LEDs are connected to the master Arduino, and they're used to diagnose any connection problems we might have had while building the project. The LED all the way on the left, or on the bottom in the video, is connected to the Arduino that controls the controller. The LED turns on when it is waiting for data to arrive from the left Arduino. When the data arrives, the LED turns off. On the top, the other LED also does the same function, except to the LED to the Arduino that it connects to the glove. It turns off once data has arrived, and it turns on while it's waiting for data to arrive. The middle LED is flickering faster than the camera can pick up, and that one simply turns on and off as it sends data to the PC.
VJoy is a virtual device driver that can read input as if it were coming from a controller. Now, what VJoy does is makes this input that it's reading available to pretty much any game that is expecting controller input.
We've written a program in C++ that will take the data that's coming in from our master Arduino, take it to our PC, and we'll reformat the data that's coming in into a format that the VJoy libraries will expect. It will then pass this data forward to the VJoy libraries, which will then write the data to a virtual driver that any games or other programs that can use any virtual controller, or any game controller for that matter, can read from and use. We'll now run the program and tell it the port with which to get data from. And it's now running. If I open up the monitor that shows what VJoy is reading, you can see values changing as Dylan uses the controllers. These left two axes are the axes coming in from the joystick. These 3 buttons at the bottom, which turn on when Dylan presses the buttons, are also from the joystick. And these next 5 axes up top are all coming from Dylan moving his fingers around.
Here we have a game that we utilize to test the game controller itself. This does not utilize the glove because there are not enough axes within this game to utilize the flex sensors involved. However, if there were a game to utilize all the flex sensors, then the flex sensors will obviously work. Just an example here, we're moving left and right. We're able to jump with the buttons. We're able to attack, and so on and so forth. And we're able to use the mouse click button to use our special ability.
And here's one last look at our project. You can admire our craftsmanship here. Thanks for watching.